Hello everyone, welcome to the fifth R-Help video for STA 371G. Today we'll be going over renaming columns, predict.lm with prediction and confidence intervals, residuals and residual plots, and critical values. So to rename a column, which may be useful because it's easier to type out shorter things rather than longer things. Let's say our x variable is number of salespeople working and our y variable is sales in thousands. Instead of typing these out each time you want to use the y or the x variable, you can just run these two commands to rename them and then create a model with the renamed. So you still use the same format for everything, you're just changing the name of your y and x. This could be useful to do R more quickly and make your models more efficiently. So next we'll go over predict.lm. If you put in the predict.lm function and then the model name, you're going to get a list of predicted y values for each x value. Note, this isn't predicting it for 1, 2, 3, 4, 5, 6, etc. It's predicting it for the order in which they're listed. So for example, for 3 salespeople working, the predicted value is this. For 4 salespeople working, the predicted value is this, and so on. If we use the predict.lm function with model, comma, list, x equals a certain thing. So if you'll remember, we renamed our x variable people instead of the longer name. Interval equals prediction. We get the prediction interval, and the fit is the predicted value. This is the interval. We can do the same with confidence interval. It may be intuitive to write prediction for prediction interval and confidence for confidence interval, but make sure you're writing this the right thing, because it's easy to get in the mode of typing it from habit or to simply copy and paste and forget to change it to the correct type of interval. Now we'll go over residuals. So if you want a list of your residuals, you can create a vector of resid, and then residuals model gives you the residuals. So now we have a vector of our residuals called resid. Note, you can also get the residuals from typing residual model. I just like to create a vector of it because it makes the next step easier. To create the residual plot, plot the x against the residuals. So plot people, which is our x, comma resid. Note, you could also do it in this manner, x, comma residuals model. It gives you the exact same thing. It's easier for me to create a vector of it though, so I prefer that way. Note that when you create the residual plot, you'll need to run the AB line 0, 0, and it will make it easier to have a point of comparison. It looks like an axis, and you can check the conditions more easily, for example, the equal spread. The QQ norm resid creates our normal QQ plot, and instead of using AB line 0, 0, we'll use AB line mean resid, SD resid, and it will give us a line for a point of comparison. Note that any place that I've typed resid, it's just because I've created a vector of the residuals named that. You can name it something else, or you could simply type residuals model, whatever your model name is each time. Hist resid, or again, hist residuals model, creates a histogram of your residuals that you can use to check conditions. The last thing I'll go over is finding the critical value, as you'll have to do on a few problems in homework 5. So if we type summary model, given that you've already created the model, you can get your degrees of freedom. This is important because you'll need to put it into the QT function. The format of the QT function is whatever number you calculate in the line above, and then your degrees of freedom. So to get what number you put first depends on the percent confidence. So let's say we have a 95% confidence interval. You use 1 minus 0.95 divided by 2. We get 0.975. So we'll use QT 0.975 and then our 8 degrees of freedom, and this will be our critical value. I hope this helps, and thank you for watching the video.